Namaste and one welcome to Pabson Distance Learning Education program collaborations with JanataTelevision. Today we have class 10 science subject we are going to discuss, and in science 4 categories are there. They are physics, chemistry, biology, and astronomy and geology. Out of that 4 category, today we are going to discuss physics, and in physics the first topic is there, that is force we are going to discuss. So let's move on to the first lesson, that is force. Okay, before starting this force, what we will going to learn on this force, let's check. So we are going to learn on this force Newton's universal law of gravitation and its application, that we will discuss on this lesson. And similarly we will discuss about gravity and the gravitation also, differentiate between gravity and gravitation, that we will discuss here. And similarly we will discuss mass and the weight, and we will calculate the different mass and the different weight of the different object in this lesson. Similarly we will measure the mass and the weight of the different object also. And similarly we will discuss the free fall and the weightlessness on this lesson. So let's move on to the lesson force. Okay, force, about this force you might have learned in the lower class also, like definitions of force, what is the unit of force, right? Similarly, the relation between the different unit of force that you might have learned. So let's know about the force little bit first. So let's revise. Okay, so I have one sheet of paper, the white paper I have, and you can see the dimension of this paper. It is rectangular in the shape, right? It's a rectangular in the shape. So whenever I apply some external agent here, then it changes the shape from rectangular to the another shape. For example, here you can see, so this one shape get changed when I apply the external agent on it, then for the shape get changed one, right? Similarly, if I squeeze this again, the size also get changed one. That means we can define the force as an external agent which change or try to change the state of matter from rest to motion or vice versa, or it also changes the speed of a moving object also, and shape and size of the object also. That means the external force when we apply, then it changes the shape and it changes the size also, it get changed one. That is the force. And unit of force you have learned in lower class. We will measure the force in Newton. So Newton is the unit of force. Newton is the unit of force, and the symbol for this Newton, sorry, this should be smaller one. This is Newton, and the symbol is N. We will write down the unit of the force. And this is SI system of unit, and we can measure in CGS system of unit in the dyne. Dyne is the CGS system of unit for the measurement of a force. So what is the relation between this Newton and the dyne is 1 Newton force, it is equivalent with the 10 to the power 5 dyne. So sometimes it may be useful while solving the numerical problem. That's why this also you need to remember. Okay. Okay. So now let's move on to the grade 10 topic, that is force. And here we will discuss the special kind of force only. Other force we have discussed in the lower class, so we will not discuss that here. And we will discuss only the special kind of force in grade 10, that is called the gravitational force, or simply we can say that the gravitation also. Okay, so let's move on. Okay, before 16th century, the people used to believe that the earth is at the center, and other heavenly bodies like sun, other planet, they revolve around the earth. That is a belief of the people before 16th century, and that belief is read as a geocentric model. So it is called geocentric model. Also we can say it as a geocentric theory also. Geo mean earth, centric mean center. So people used to believe that earth is at the center, and other heavenly bodies, they revolve around the earth, which is called this geocentric model. But at the 16th century, the scientist called the Nicholas, he just propounded that the sun is at the center and other heavenly bodies, they revolve around the sun. That is called the heliocentric model. Helio mean it is the sun, and the centric mean at the center. So the sun is at the center and other heavenly bodies, they revolve around the sun, which is known as the heliocentric model. And after this heliocentric model, the people started to search why the sun is at the center, why the sun, other planet, they are revolving around the sun. The people, they started to search. And later on, by Newton, Sir Isaac Newton, on 1687 AD, he found the force of gravitation, which is also known as the universal law of gravitation. Then the people came to know why the sun is at the center and why the other heavenly bodies, they are revolving around the sun. And this proof of this Newton's universal law of gravitation is existence of solar system, right? And similarly, whenever we throw the object in the vertically upward, then that will move towards the center of the earth. That is the proof for the universal law of gravitation one. Now let's see what is the gravitation mean. Okay, before stating this gravitation, so let me show the one example here. So I have two markers here, and the Newton say that these two markers attract each other by the certain force, and that force is known as the gravitation or gravitational force. Simply we can say it gravitation also or gravitational force also. So let's see what is gravitation. So gravitation. So gravitation is the mutual force of attraction between the two objects found on the universe. That may be the very huge object, which is called the celestial body also. That may be the smaller object, that is the microscopic object also. So force of attraction between two objects found in the universe is simply called the gravitation or gravitational force. It's being force, the unit is same as the Newton. Okay, so example I have already said that whenever we throw the object, then the object will fall straightly on the object will fall straightly on the towards the center of the earth, right? That is the proof of this gravitation. Similarly, whenever the sun is there at the center, the sun, other heavenly bodies also get revolve around the sun. That is also the proof of this gravitational force. Similarly, the rain fall towards the surface of the earth, and the water that will flow from the higher altitude to the lower altitude. That is also the example of this gravitation one. Okay, so this one is gravitation. Now the Newton, he has propounded the law which is called the Newton's universal law of gravitation. So what is this Newton's universal law of gravitation? Let's see. So every object in the universe, so firstly I will state that Newton's universal law of gravitation, then we will derive the formula. So what this Newton's universal law of gravitation says is every object in the universe attract each other by the force called the gravitation, which is directly proportional to the product of mass and the inversely proportional to the square of distance from their center. That is the Newton's universal law of gravitation. So you can see in the slide also over there, I have stated over there that Newton's universal law of gravitation. So let's see the mathematical derivations for this Newton's universal law of gravitation. Mathematical derivation. Mathematical derivation means that we are going to prove F equals to Z m1 m2 by d square. So this we are going to prove, and this one is also known as the Newton's universal law of gravitation. Okay, so let's draw the two object here, 1 and 2. Let's say this object is A and this object is B. Two object is there. So this we are going to derive. Okay, so let m1 be the mass of first object. So this is m1, let's say this is m1, and the mass of second object is m2, right? First object, and m2 be the mass of second object. Okay, and I have said this distance we will measure from the center of the object, right? That means if this is the center, then from here and from here the distance is d. So this one is the distance. So remember that always we have to measure the distance from the center, right? From center we have measured one. Now if F is the force of attraction between these two objects, so mass of the second object is given, and d be the distance between them from their center. Okay, if F be the force of attraction between them, then according to Newton's universal law of gravitation, okay, let me drop this previous one. So what the Newtons say is the force of attraction between them is directly proportional with the product of masses. That means, can we write down F is proportional to m1 into m2? This is equation 1. This is the first equation. And also it says that it is inversely proportional to the square of the distance from their center. That means, again we can write down F is inversely proportional to the square of distance. Sorry, this would be d. Okay, so this is d square. Generally in we can write down this symbol as capital M and the small m also, right? Small m and the small m1 and small m2 also we can write down, and this distance d also we can mention, and somewhere else you can found this small r also, but capital R it is used specially for the radius of the earth. So let's think about this also. This is equation second, right? So let's combine this equation first and second. Okay, from equation 1 and 2, then what we will get from this 1 and 2? F is proportional with m1 m2 divided by d square. So this is the combination of equation 1 and equation 2. Now the proportional sign is there. For the numerical problem solving, we cannot use this proportional sign. That's why this should be changed into the equal sign. While we change this into the equal sign, then some constant term we will insert here. That means, or F equals to, instead of proportional sign, I have used this equal to sign. And here you have to insert some constant, which is called the Z. Here, Z is the gravitational constant. It is also called the proportionality constant, called the gravitational constant. So this one is Z m1 m2 by d square, which is the formula for calculating the gravitational force, right? Where G is called proportionality constant, called G is called the proportionality called gravitational constant. constant. So this one is the mathematical form for the universal gravitational law. Clear this one? Okay. So now, so what is this G? Let's define this G now. Okay, let me write down the formula once again. F equals to Z m1 m2 by d square. We are going to define this capital G. What is this capital G? We are going to define. Okay, so for defining this, so let's solve few steps. Let's separate this G. So can we write down this F into d square equals to Z m1 m2? We can write down, right? So let's simplify this further. F into d square by, this is m1 into m2 equals to Z, right? So this one G, F into d square by m1 into m2, right? So let's arrange this. So G equals to F into d square by m1 into m2, right? Okay, now if m1 equals to m2 equals to 1 kg, if I take this unit mass, right, and distance between them also, let's say unit distance 1 meter, and this one m1 and m2 also if I take 1 meter, then if you substitute these value here, then we will get this Z equals to F into 1 to the square divided by 1 into 1. That is Z equals to F. So gravitational constant G can be defined as the gravitational force exerted between the two unit masses separated by the unit distance. Clear? Let me explain once again. Gravitational constant G can be defined as the gravitational force exerted between the two unit masses separated by the unit distance. That is the definitions of gravitational constant. So what is the unit of this gravitational constant? Let's see. So from here, so let me rub up to here. So what is the unit of gravitational constant that we are going to find? Okay, so unit of force, it is the Newton, right? And unit of distance, that is meter, but here is square is there, so we'll write down this square, meter square. And here is this unit of mass is kg, and another again mass is left there, that is the kg. That is, so we can conclude the unit of this gravitational constant is Newton meter square per kg square is the unit for this gravitational constant, right? Also we can mention like this also. This can be mentioned like this: Newton meter square and this kg to the power minus 2 also per kg square. So this one is unit for this gravitational constant. Okay, and what about the value? This is the constant value I have said. So value of this G, so let me rub this. So value of this G, value of Z equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is the constant value everywhere. Wherever you visit, right, the value of capital G will be same. That is 6.67 into 10 to the power minus 11 Newton meter square per kg square. That is the value. And this value is firstly calculated by the scientist called the Henry Cavendish, which he used the torsion balance for the calculations of this value G. You can see in the slide also, I have shown the one picture of this torsion balance for the calculations of value Z, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. And this is very small force that found in the earth, right? This value is very small. Due to this smaller value, the gravitational force is the minimal force found on the earth. Okay, so this is the value. Now, I frequently use the term, this G is called the universal gravitational constant. Why it is called the universal gravitational constant? Let's see. The value of G, it is not affected by the mass. Okay, whatever the material are there for formation of that mass, it doesn't affect, right? And the value of G also does not affect by the medium in which the object are kept. Suppose if I put the object on the air, no problem. The medium is air, the value of G is same. And if I put the object in the water, also the value of G doesn't get affected one. So due to this reason that it is not affected by the any kind of medium, any kind of material, right? So this value is the constant everywhere. So it is called the universal constant. Clear? Okay. Now, this value also I have said. Now, let's see the variations of gravitational force with the mass and the distance. So, you can see slide. There is, I have given the one questions here. So, slide you can see. What is the change in the gravitational force when one of the mass is double by keeping the distance constant? So we are going to check the variations of gravitational force with mass and the distance. So let's derive that, okay? What we are going to do? We are going to do the change in the gravitational force when one of the mass is double by keeping the distance constant, okay? So how we can solve? Let's see, solution. So we can write down if the m1 is the mass of the first object, m2 is the mass of the second object, d is the distance between them, then F is the force between them, then F equals to z m1 m2 by d square. So this equation 1 I will write down, okay? And what the question says is, according to question, one of the mass is double, I have said, right? Out of that two masses, one is double. Let's say this one is m1 and this one is, let's say, m2. This is the initial condition. And at the starting, the m1 is the mass of the first object and m2 is the mass of the second object. Now, if I say the one of the mass is double, that means, let's say this m1 I will double that. That is, the size I will increase by 2 times. That is 2m1 and this one is m2 as it is. And the distance between them again constant. So this is the distance, right? And distance is as it is. So according to the question, let's say this is m1 dash. It is a new mass. In the second condition, it is a new mass. So m1 dash equals to twice of m1. That the question says. One of the mass is double one. So I have double this first mass. So this is next one is m2 dash is as it is. That is the m2, because only one we have doubled one, right? And distance between them, d dash, is again distance similar one, right? So then if F dash is the force of attraction between these two, then the formula is Z m1 dash and m2 dash, it's a new mass, divided by d dash to the square, right? Let's substitute the value of these, or F dash equals to, so Z is as it is, m1 dash from here, that is twice of m1 dot, m2 dash is m2 divided by d to the square, right? So let me write down in up. Okay, so or F dash equals to, now let's simplify this. This is 2z m1 m2 by d square is there. So what is the first equation that we have written previously is exactly this is equivalent with the force F. So we can replace this. F dash equals to twice of F. So when the one of the mass is double, then the gravitational force also get doubled one. So what we have learned previously on the statement is the gravitational force exerted between the two masses is directly proportional with the product of mass. That means when the mass is increased, then the gravitational force also get increased one. So that is a verification of first statement, right? So here is another question is there in the slide. What is the change in the gravitational force when the product of mass is half and the keeping the distance constant? That is assignment. Please try to solve as it is, whatever we have done just now. And next one is there. So next one is, let's check of distance. What effect will be there when we change the distance? Let's see. Now next question is there, what is the change in the gravitational force when the distance between them is half by keeping the mass constant? So we are going to decrease the distance is decreased by half, then what kind of changes is there in the gravitational force? Let's check. Okay, so again solution. So from gravitational force in Newton's universal of gravitational force, we can write down F equals to z m1 m2 by d square. Whenever the m1 is the mass of first object, m2 is the mass of second object, and d be the distance between them from their center, then the gravitational force is given by this relation, right? Now according to question, I have said the distance is decreased by half, right? So we can write down this m1 dash equals to m1 as it is because mass is constant, and m2 dash is m2, mass is constant, and d dash is distance is half, right? Distance is half. So so from this we can write down this F dash equals to z m1 m2 by d by 2 to the square. So whenever you solve this, okay, try to solve this yourself. In next class we will discuss this also, and whenever you solve this you will get this F dash equals to 4 times of F. Okay, this relation you can get when you solve this equation and this equation and this equation. That means when we decrease the distance, then the gravitational force get increased by 4 times. If you decrease by 2 times, then the gravitational force get increased by 4 times. So it is the inversely proportional to the gravitational force exerted between the two masses. Okay, so today we have discussed these things. For example, this gravitational force we have discussed, right? And also we have discussed derive the gravitational force, the mathematical relations for the gravitational force, that is F equals to z m1 m2 by d square, that we have derived one. And also we have derived the relation or variations of gravitational force with the product of masses and the distance also, right? Some assignment I have given previously also. Let's try to find by changing this mass yourself. So you can double also, you can triple also, you can decrease the mass by half, right? So let's try to solve by yourself by varying the mass as well as the distance. Okay, and then you try to solve, then you will also know that what kind of changes will be there on this gravitational force. Will you? Okay, so let's solve that also. Okay, so you can get the more idea about the variations of gravitational force when you change the masses. Okay, so let me write down the formula again, whatever we have discussed, so that later on, whenever we practice numerical problem, then we can use that formula. Okay, what we have derived today, that F equals to Z m1 m2 by d square. So today we have discussed this formula, and in this formula some numerical problem, related numerical problem also there, that also we will discuss on the next class. Okay, so and here remember that this G is the universal gravitational constant, and m1, this m1 is the mass of first object, mass, this m1 is mass of first object, right? m2 is mass of second object, and this d is the distance between them from their center. So today we have learned this universal gravitational force, right? And in next class we will solve some numerical problem related to this, right? And we will discuss the furthermore, like gravity and the weight, that we will discuss on the next class. So I think today you might have learned some information about this force. So in the next class we will continue the furthermore. So thank you very much everyone for learning this, the force with me. Thank you very much everyone.